am Mrs. C.GEETHA, Assistant Professor of Computer Science, belong to A.D.M. College for Women, Nagapattinam. Let us see about embedded system, basic and its applications. Introduction. What is meant by system? A system is a way of working, organizing or doing one or more tasks according to a fixed plan, program or set of rules. A system is also an arrangement in which all its units assemble and work together according to the plan or program. Examples of systems are watch. It is a time display system. What are the parts that are used in, generally that we are used in watch? They consist of hardware, needles, battery, dial, chassis and strap. Generally a watch will function as follows. All the needles move clockwise only. A thin needle rotates every second. A long needle rotates every minute. A short needle rotates every hour. All needles return to the original position after 12 hours. Another example of system is washing machine. It is an automatic clothes washing system. It includes a status display panel, switches, dials, motor, power supply and control unit, inner water level sensor and solenoid valve. Washing machine works accordingly by wash by spinning, rinse, drying, wash over by blinking. Each step display the process stage. In case the interruption, execute only the remaining of them. Definition of embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also function within a larger system. The systems can be programmable or have a fixed functionality. It is a microcontroller or microprocessor based system designed to do a specific task. Now let us see the diagram of an embedded system, how a software program is getting embedded into the hardware, that is the chip. The diagram is displayed for your reference. What are defined as computer hardware? It can be of microprocessor. A microprocessor is a digital electronic component which transistors integrated on a single semiconductor IC that is small and consumes less power. An embedded microprocessor is a computer chip used inside several devices and equipment to provide added functionality. A large memory can be of primary and secondary. It can be defined as RAM, ROM and cache memory. What is RAM? RAM can be defined as random access memory. It is read-write memory. Data at any memory location can be read or written. It is a volatile memory that is retains the contents as long as the electricity is supplied. Data access to RAM is very much fast. ROM. ROM is described as read-only memory. Data at any memory locations can be only read-only. It is a non-volatile memory, that is the contents are retained even after electricity is switched off and available after it is switched on. Data access to ROM is slow, that is compared to RAM. Cache memory. It is an extremely fast memory type that acts as a buffer between the RAM and the CPU. It holds frequently requested data and instructions so that they are immediately available to the CPU when needed. Cache memory is used to reduce the average time to access the data from the main memory. Input units. It can be of keyboard. Keyboard is the most common and very popular input device which helps to input data to the computer. Mouse. Mouse is the most popular pointing device. Scanner. It is an electrical device that reads and converts the documents such as photo and pages of text into a digital signal. Output unit. An output device is a piece of computer hardware that receives data from a computer and then translates the data into the another form. Output types are monitor. The monitor is defined to display symbolic and graphical information. It shows all the data and information as soft copy on its screen. It acts as an interface between the CPU and the user. A cable is connected with a video adapter setup with the computer's motherboard to display the data. Anyone can view files, photos, videos, text, graphics and the tables in the real time through the monitor. Printer. It is also another output device. It is an electronic device that accepts text file or image from a computer and transfers them to a medium such as a paper or a film. It can be connected directly to the computer or indirectly via a network. Networking unit. It can be of Ethernet card. An Ethernet card is the communication hub for your computer. It connects to a network using a network cable. Driver. A network device driver is a group of files that enable a network device to communicate with the computer's operating system and other computers and devices. They are essential for hardware to hardware and hardware to software interfacing. Modem. Modem or broadband modem is a hardware device that connects a computer or router to a broadband network. Components of embedded system. It can be of hardware, that can be of processor, timer, interrupt controller, input-output device, memories, ports, etc. It has the application software which may perform concurrently the series of tasks or multiple tasks. RTOS, it can be defined as real-time operating system. It defines the way the system works, which supervises the application software. It sets the rule during the execution of the application program. A small-scale embedded system may not need an RTOS. The diagram of embedded system hardware is displayed. In this diagram, we see about the processor. Processor are the major part in the embedded system that take response from sensor in digital form and processing of this response to produce the output in real-time processing environment is performed using the processor. For an embedded system developer, it is essential to have the knowledge of both the microprocessor and microcontroller. Timer. A timer is a specialized type of clock which is used to measure time intervals. The timer module has 3 modes which must be configured correctly for the specific application. Up mode. The timer will start with a value of 0 and increment until a software defined value. Continuous mode. It defines the timer will start at 0 and increment until it rolls over at 0x 4F. Up and down mode. In this timer, it will start at 0, increment until a defined value and start decrementing back to 0. Interrupt controller. An interrupt controller provides a programmable governing policy that allows software to determine which peripheral or device can interrupt the processor at any specific time by setting the appropriate bits in the interrupt controller registers. Serial communication port. It can be used for interprocessor communication within a system or for communication with the different parts of the system. Parallel port. It is a type of interface found on computers for connecting various peripherals. Parallel ports provide the ability to input or output binary data with a single bit allocated to each pin within the port. Power supply and oscillator circuit. A power supply unit that can be defined as a PSU. It converts main voltage to low voltage regulated DC power for the internal components of the computer. Oscillator circuit. It is an electronic circuit which generates a repetitive signal. This signal can be in any form depending on the application. The oscillators are electronic circuits that make a respective electronic signal, generally the sine wave and the square wave. System application specific circuit. An application specific circuit is an integrated circuit chip customized for a particular use rather than intended for general purpose use. For example, a chip designed to run in a digital voice recorder or a high efficiency video code recorder. Input interfacing and output interfacing. It is a method which helps in transferring of information between the internal storage device, that is from memory and the external peripheral device. A peripheral device is that which provide input and output for the computer. It is also called as input-output device. The development of electronics diagram is displayed for your reference. Embedded system constraint. Embedded system is a software designed to keep in view of three constraints. Number 1, system memory. Number 2, processor speed. Number 3, they need to limit the power dissipation. When running the system continuously in cycles of wait for events such as run, stop and wake up. What makes embedded system different is it is different due to its real-time operation that can be defined as RTOS. It supervises the application software and provide mechanism to let the processor run a processes as per the scheduling by following a plan to control the latencies. RTOS defines the way the system works. It also sets the rules during the execution of application program. A small scale embedded system may not have RTOS, so we can define an embedded system as a microcontroller based, software driven, reliable and real-time control system. Size. The code size is used to measure in bytes and kilobytes. Cost. An embedded system is a special purpose system in which the computer is completely encapsulated by cost saving and it may be multiplied by millions of items. Time. All timing facilities are driven by a hardware clock. This is simply an oscillator that generates an interrupt at regular intervals. It can be of reliability, safety, energy and much security. Classification of embedded systems, they are small scale embedded system. It consists of a single 8-bit or 16-bit microcontroller, little hardware and software complexity. They may even be battery operated. Usually C is used for developing this system. They need to limit power dissipation when system is running continuously. Medium scale embedded system. Single or few 16 or 32-bit microcontroller or digital signal processor or reduced instruction set computers are used for this purpose. Both hardware and software complexity. Programming tools. What are the programming tools that are used in medium scale embedded system are RTOS, source code engineering tool, simulator, debugger and IDE that can be defined as integrated development environment. Sophisticated embedded system. It has an enormous hardware and software complexity which may be need scalable processor or a configurable processor and programming logic array constrained by the processing speed available in their hardware units. What are the program tools that are used in this embedded system are, for this system may not be readily available at a reasonable cost or may not be available at all. A compiler or a retargetable compiler might have to be developed for this. Processor. A processor is the heart of the embedded system. For an embedded system designer, knowledge of microprocessor and microcontroller is a very must. There are two essential units. That is number 1, control unit that is used for fetching operation. Number 2, execution unit. It can be used to execute the operation in the processor. What are the various processors that we are using in the embedded system are GPP that can be defined as general purpose processor, microprocessor, microcontroller, embedded processor, digital signal processor. Application specific processor ASSP, multiprocessor system using GPPs. Microprocessor. A microprocessor is a single chip semiconductor device also which is a computer on chip but not a complete computer. Its CPU contains an ALU, a program counter, a stack pointer, some working register, a clock timing circuit and an interrupt circuit on a single chip. To make complete microcomputer, one must add memory, usually RAM and ROM, memory decoder, an oscillator and a number of serial and parallel ports are necessary. Processor technology. The architecture of the computation engine used to implement a system's desired functionality. Processor does not have to be programmable. Processor not equal to general purpose processor. The diagram of processor technology is displayed for your reference. Processor may vary in their customization for the problem at hand is displayed in the processor technology and its types are displayed for your reference. General purpose processor. Programmable device is used in a variety of application also known as microprocessor. What are the features that we are using GPP? It can be of program memory, general data path with a large register file and general ALU. What are the benefits? User benefits by using the load time to market and NRE cost. A high flexibility. Pentium, the most well known but are hundreds of others. Single purpose processor, digital circuit designed to execute exactly one program, that is coprocessor, accelerator or peripheral device. Features. What are the features that we are using in the single purpose processors? It contains only the components needed to execute a single program, no program memory. The benefits that we are gaining from single purpose processors are fast, low power and it is very small in size. Application specific processor. Programmable processor optimized for a particular class of application having common characteristics. Compromise between general purpose and single purpose processor. The features of application specific processors are program memory, optimized data path, special functional unit, and the benefits are it is very flexible, good performance, size and good power. IC technology, the manner in which a digital implementation is mapped onto an IC chip. What is defined as IC? IC is an integrated circuit or chip. IC technologies differ in their customization toward design. ICs consist of numerous layers, perhaps 10 or more than that. IC technologies differ with respect to who builds each layer and when. There are three types of IC technology. Number one, full custom or VLSI, semi-custom or ASIC or PLD, that can be defined as programmable logic device. Full custom or VLSI, all layers are optimized for an embedded system's particular digital implementation, that is placing transistor, sizing transistor, routing wires. What are the benefits that we are gaining from full system are excellent performance, small in size, low power consumption. Drawback, eventually having advantage means usually we will have its drawback also. Likewise, high NRA cost, long time to market. Semi-custom, lower layers are fully or partially built. Designers are left with routing of wires and maybe placing some blocks. What are the benefits we are gaining from semi-custom? They are gaining as good performance, good in size, less NRE cost and than a full custom implementation. Drawback is that is still require weeks to months to develop it. PLD can be defined as the programmable logic device. In this device, we all have all layers already exist. Designers can purchase an IC. Connection on the IC are either created or destroyed to implement the desired functionality. FPGA can be defined as a field programmable gate array, that is very popular. What are the benefits we are gaining from PLD? That are low NRE cost, almost instant IC availability. Drawback, it is very bigger in size, expensive, lower, slower, power hungry. Microcontroller. A microcontroller is a functional computer system on a chip. It contains a processor, memory and programmable input-output peripherals. Microcontrollers include an integrated CPU, memory and peripherals capable of input and output. What are the various microcontrollers are Intel 8031, 8032, 8051, 8052, 8751, 8752. What are the PICs are 8-bit PIC that can be of 16 and PIC 18. 16-bit DSP IC33 or PIC 24 or that can be of PIC 16C7X. Motorola can be of MC68HC11. Difference between the microprocessor and microcontroller. Microprocessor, the functional blocks are ALU, register, timing and control unit. Whereas in the microcontroller, it includes the functional blocks of microprocessor, and in addition, it has the timer, parallel input-output, RAM, EEPROM, ADC and DAC. Bit handling instruction is less, 1 or 2 type of only can be displayed in microprocessor, whereas in microcontroller many type of bit handling instructions are there. Rapid movements of code and data between external memory and MP are used in microprocessor, whereas in microcontroller rapid movement of code and data within the MC itself. Whereas in the microprocessor, it can be displayed as it is used for designing general purpose digital computer system, whereas in microcontroller they are used for designing application specific dedicated system. Embedded processor. Special microprocessor and microcontroller are often can be referred as embedded processor. An embedded processor is used when fast processing, fast context switching and automatic ALU operation are needed. The examples are ARM7, Intel i960, AMD 29060. Digital signal processor. DSP as a GPP is a single chip VLSI unit. It includes the computational capability of microprocessor and multiply and accumulate units. DSP, it has a large number of applications such as an image processing, audio, video and telecommunications processing system. It is used when signal processing function ought to be processed fast. Their examples are displayed for your reference. Application specific system processor can be defined as ASSP. It is dedicated to specific task and provide a fast solution. It is used as an additional processing unit for running the application in place of an embedded software. Multiprocessor system using GPPs can be of multiple processors are used when a single processor does not meet the needs of different tasks. The operation of all the processors are synchronized to obtain an optimum performance. Moore's law. Moore's law describes a long-term trend in the history of computing hardware. Since the invention of the integrated circuit in 1958, the number of transistors that can be placed inexpensively or an integrated circuit has increased exponentially, doubling approximately every 2 years. The trend was first observed by Intel co-founder Gordon E. Moore in the year 1965. Almost every measure of the capabilities of digital electronic device is linked to Moore's law. That is, it can be defined by processing speed, memory capacity or displayed by using the Moore's law only. The Moore's law procedure is displayed for your reference. Moore's law drives the development of a system in chip architecture. The growing number of transistors on an SoC drives the trend towards more RTL blocks on the chip are displayed for your reference. And what are the other hardwares that we are using in the embedded system? That is power source, clock oscillator, RTC that can be defined as real-time clock, reset circuit, power up, reset and watchdog timer, reset, memory, input output ports, input output bus, interrupt handler, DAC and ADC, LCD and LED display, keypad or keyboard. Software that are all used in embedded system, they are using the software such as C, CPP and .NET. What are the compilers that the software using in embedded are RIDE and KEIL. What are the stimulators that are used is a MASM. Household appliances, microwave ovens, televisions, DVD players and recorders, audio players, and an integrated system in aircraft and missiles. Cellular telephones, electric and electronic motor controllers, engine controllers in automobiles, calculators, medical equipments, video games, digital musical instrument, etc. can be displayed. The application of embedded system are displayed for your reference. How embedded system works in a BMW cars? BMW 850i brake and stability control system. It has ABS. ABS means anti-lock brake system. It pumps brakes to reduce skidding. And automatic stability control that can be defined as AC plus T. It controls the engine to improve the stability. ABS and AC plus T communicate. It was introduced first needed to interface the existing ABS module. The working of 850i is displayed for your reference. Automatic embedded system. Today's high-end automobile may be 100. Microprocessor. What are the bit microprocessor are used for automatic embedded system are 4-bit microcontroller. It checks seat belt. Microcontrollers run dashboard device. 16 or 30-bit microprocessor. It controls the function of engine. What are the sources of embedded system? It reacts on the environment at the speed of the environment. Often real-time requirements. They are designed for one single task. It have often to be power efficient. They are mass product and have to be cheap. It must be reliable. What are the future trends in embedded system? The industry for embedded system is expected to continue the growing rapidly, driven by the continued development of artificial intelligence that is defined as AI, virtual reality that is defined as VR, and augmented reality that is defined as AR, machine learning, deep learning, and the Internet of Things that is defined as IoT. The cognitive embedded system will be at the heart of such trends as reduced energy consumption, improved security for embedded device, cloud connectivity and mesh networking, deep learning application and visualization tools with real-time data. Thank you, one and all.